So let's take a look at this. Find the zeros and sketch the graph. Find the zeros and sketch the graph. Find the zeros and sketch the graph. Well, what does it mean, find the zeros? Actually, finding the zeros is the same thing as finding the x-intercepts. And hopefully we remember how to find the x-intercepts. I would ask in class, how do you find the x-intercept? And then somebody would raise their hand or just shout it out, you make y 0. And I'm thinking, there is no y in this problem. Oh, yes there is. It's at the f of x. It's at the f of x. So, to find the x-intercepts, which are the same as the zeros, you make y 0. So I'll just say 0 equals 3x to the fourth minus 6x squared plus 3. Great. And then, well, it's just like you're solving a polynomial equation. So everything's already to one side. You try and factor out and do whatever you can. So I can actually divide by 3 here. Can't divide by a variable, though. So I get x to the fourth minus 2x squared plus 1 still equal to 0. And then, I can use my x factoring on this. It's just I have to use an x squared when I do my shortcut. And I can use the shortcut. So, what do we have? We have 1 in the top, negative 2 in the bottom. Is that 1 times 1? Both negative, right? Negative 1 times negative 1 is positive 1. And then, yeah, that works. So, what do I have? I have, well, 0 equals 3 times, and then I'm going to use my shortcut. Except for I'm going to put an x squared in here. X squared and an x squared. And then minus 1, minus 1. Ooh. Well, this is a difference of squares, right? So I have 0 equals 3 times, I take the square root, that's just x. Take the square root, that's just 1. And a plus and a minus. And I do the same thing for this one. So really, I get the same answer a couple times. And that's important. Whoops, not x squared, just x, right? I square root it. Plus 1, x minus 1. So if we were to set each piece, I'm going to skip a step on this one. It's okay if you do this too. It's a lot faster. But if you set each piece equal to 0, in this step, I would subtract the 1, and I would get negative 1. And then here, I would add the 1, and I would get positive 1 if I set each piece equal to 0. And then x equals negative 1 again, same thing as that. And x equals positive 1, same thing as that. Okay, whoa, whoa, whoa. Look at this, those are the same. And it happens twice, 2 times. When things happen twice, it's called even multiplicity. And that actually helps us with our graph. But for now, that's even multiplicity. And these were x-intercepts. So, in fact, we can actually start sketching the graph now. So I'll draw my little coordinate plane. And it doesn't have to be super, super accurate. We're just sketching it. And then I'm going to place, so what were the steps? Change y to 0. And then factor everything and solve like we did before. And then plot those on the x-axis. So I have something at negative 1. And it happens twice, because I have even, it happens 2 times. 2 is even. If it happened 3 times, I would say odd multiplicity. And then I have positive 1, and that also happens twice. So, now what? Now what? I have to decide my end behavior. What is my end behavior? And I'm just going to draw the picture for that. Behavior. Well, remember behavion. Behavior. So I know that I have an even degree polynomial. So that's either something like this or something like that, opening up or opening down. And then I also know that, well, I have a positive lead coefficient. So it must be something like this, opening upwards. So on the left side of the graph, I'll do that over here. It looks like that. So on the left side, I should be going upwards. And on the right side, I should be going upwards to mimic this. Now here's a rule. When it happens more than once, and it's like an even number of times, when I have even multiplicity, I bounce off x-axis, or x-intercept, I should say. So bounce off x-intercept. If I had an odd multiplicity, then I would cross, and I'll show you an example like that, but cross x-intercept. Okay, what the heck is he talking about? Well, I already know that the end behavior would look like that. I just don't know what it does in the middle. But since I have even multiplicity, I'm going to bounce off of my x-intercept. So here's my x-intercept, and I'm coming from here, and then I'm going to bounce. If I had an odd multiplicity, I would cross through. But I don't, so I'm going to bounce. And then I have to go to this one next. Okay, well, must go, and then I bounce again because I had even multiplicity there as well at both 1, that was this, and at x equals -1, that was this. It happened twice, so I bounce. If it happened 3 times, I would cross. If it happened 4 times, I would bounce. 5 times, it would cross, and so forth. I'll do another example like this.